looking at exponent rules. So when it comes to exponents, there's rules, and these rules are basically shortcuts. So I'm going to go through the shortcuts, not really the explanation of why these work, but just the shortcuts, what they are. So this is what you call multiplication of like bases. And so what I mean is the base is the x, the 3 is the exponent, so the like bases mean they have the same power. If you're multiplying like bases, the shortcut tells me to add the exponents. So this is technically multiplication. So when I multiply this next one, the 5 and the 7 right here, those are not exponents. Those are just regular numbers. So that's 35, and then these are the exponents with like bases to the 9th. So in this case, we have some negative numbers and some negative exponents. So 2 negative times 9, that's negative 18. And this is the same rules I was doing up here. I was adding the exponents. So in this case, 4 positives and 2 negatives is right there. So you can do this with multiplication as well as division. Okay. So in this case, I'm dividing. So 6 divided by 3 is 2, and x to the 5th divided by x to the 2nd is x to the 3rd. And the shortcut for this one, to kind of show you here, is to divide the coefficients and you subtract the exponents. The numerator exponent, the one on top, has to go first. And you end up with that answer. All right. Once again, that's the shortcut. Okay. Negative 7x to the 3rd all over 14x to the 7th. So if I was to divide these, okay, that's going to equal negative 1/2. Okay. I can take a 7 out of both of those. And then I have 3 on the top and 7 on the bottom. So if I was to do the shortcut here, I'd end up with negative 1/2 x to the negative 4. Now it's not customary or proper to leave your answers with negative exponents, so I'll just kind of come over here. But so my answer would be to the 4th. Okay, so this is where we get this rule of a negative power. Well, a negative power is really just a reciprocal. So the rule here is like x to the negative 3rd is just 1 over x to the 3rd. That's all it means. It's just more in the bottom. So if you go back over here, I had 7, right? I had 3 on top. So I would reduce 3 of them, and I'd left 4 on the bottom. Okay. So this negative exponent is really just a denominator, or vice versa. It's a reciprocal in a sense. So if I had something to the negative 5th, that would be the same as this. Okay. Once again, the shortcut is that it's going to the opposite side, to the numerator or denominator. I mean, that's a shortcut. That's not really, exact reason why it's happening. So 3x to the negative 3y to the 7. Okay. Well, there's nothing to multiply or divide here, so the 3 is just going to be there. This x to the 3rd is really in the denominator, and this one stays in the top, in the numerator. (13x to the 5th all over y to the negative 3). Well, once nothing divides or reduces here, but this is a negative exponent, so I got to rewrite that. So what that really does is moves it to the numerator. So a common misconception is people start doing this with negative numbers after they learn this rule. So this is a negative 5. This is not an exponent. So nothing reduces. So that negative 5 just stays right where it's at. But this y to the third, that's negative, and this one here, those are reciprocals. Oops, sorry. Wrote that backwards. X to the fourth, y to the third. Dealing with those negative exponents. Um, 14, a to the 7th, b to the 7th, all over 21, a to the 6th, b to the 9th. So in this case, I can reduce the 14 and the 21. I can take a 7 out of both of those. So I get 2 over 3. I got 7 a's on top, 6 on the bottom. So if I did this one minus that one, it would be an a on the top. I got 7 on the top, 9 on the bottom. So I'll have 2 more on the bottom when I reduce them. And there's my answer. So that was all like bases. Now let's look at something called power to a power. So power to a power is stuff that looks like this. So you see how there's just the 1x, right? So in this case, you multiply the powers, and it's x to the 15th. Once again, this is a shortcut. So the biggest issue with this is coefficient. So it's this 2 here. So really what happens is you're multiplying the exponents on everything, and you can think of it as that as a 2 to the 1. This 3 is only on the x. So this is, you want to think of this as 2 to the 2, x to the 6th, and I would multiply that number out as 4x to the 6th, right? That's, I can actually work that out. Then I get negative 3x to the 4th all raised to the 3rd. So this ends up being negative 3 to the 3rd. And I multiply those powers, right? And I did technically multiply that one, it's a 1. So this is 3 times 3 times 3, so this is negative 27 because it's 3 negatives, x to the 12th. And 2x to the negative 5th power. And in this case, same thing, there's really a 1 right there, so it's 2 to the 2, and I'm multiplying those, so I end up with 4. And remember, I don't want to leave my answers with negative exponents. So 4x to the negative 3. Okay. So in this case, it's going to be 4 to the negative 3, x to the negative 3. So I'm going to go ahead and rewrite those with positive exponents. So 4 to the 3rd, x to the 3rd, and that would equal 1 over 64x to the 3rd. One last example. 5x to the 3rd, y to the 8th, all raised to the 3rd. So there's a 1 right there, so think of this as 5 to the 3rd, x to the 9th, y to the 24th. And I can multiply this one out. That's 5 times 5 times 5.